Dear friends, now in this video we are discuss about the enhancement mode type of the MOSFET. Now in our previous video we have discussed about the depletion mode type of the MOSFET. Now what is the difference in these two types of MOSFET? Now here is the no channel between the drain and source. It means what? There is a no channel will be here available as depletion mode is available. So here is the no channel between drain and source. So this channel will be created by using this gate terminal. So this is the enhancement of this channel here in between source and drain. So that's why it's called the enhancement mode type the MOSFETs. Now we discuss here for the N channel. So N channel having here is the P is the substrate as a base and two N-type materials using semiconductor devices for the source and drain. So here gate are the isolated with the using of SiO2 same as the depletion mode. Now here is the condition is that when VGS is a 0, it means gate to source will be the grounded. It means no voltage available at the gate. It means VGS is equal to 0. That's why we call that it is in the off condition because there are no channel available in between this. Now what happen when we given the voltage between the gate and source voltage? So here we are given the positive voltage VGS will be the increase here. So this positivity charge will be increased in the upper side of the gate. They are not cross to the substrates because here is the insulating media or SiO2 layer is here. Now at that time we are still not given the drain voltage with respect to source. So what happened? At that time then VGS is positively increase. So positivity is here increase. So here is the bottom side is the P substrates having a majority charge carries the holes and minority charge carries the electrons. So holes are repelled to the bottom side and the minority charge carriers electrons are go upwards to the gate side, but they do not cross this because of this insulating layer. So these electrons are deposited here. The number of electrons are more deposited here depends on the value of the gate voltage. So these electrons is deposited here and create a layer. It's called as the inversion layer. So at that time when the inversion layer is created, this is called that voltage of VGS is called threshold voltage. So when VGS is increasing, the threshold voltage at the value of VGS create the channel. So this is created by the electrons are here is the N type. So this way we create the channel. Now VGS is increasing at that time. Here is the N type material and with respect to this P type material make a junction. So both are junction. Here we show that the reverse bias junctions. So here is the depletion width is to be created. So this way we consider that when the voltage is not given, these are in the off conditions, and when the voltage is given, the channel will be created. Now VDS is applied between the drain to source. Here now we have applied between these two terminal. The voltage is applied positive terminal with respect to the so positive voltage is to given here in the drain terminal. So that's why here the reverse bias is increase. So depletion width will be increase. Due to that what happen? The depletion width will be increase. So here is the numbers of electrons will deposited will be decrease. So here the area will be decrease with respect to source. So here is the sharp is decreasing at the upper drain side. So more reverse bias, so size of channel is reduced. Now further we are increasing the voltage of VDS. So what happen? There are condition is available here is that no current can be flow from this source or drain in between these two. Because of this condition is available here is pinch off condition. So these are from that here is the electrons are going through here through channel, and the force of electrons they are going there this way is a saturated condition, so current will be constant. So as shown in the graph, we can see that here is the VDS versus ID. So when we are increasing the value of VDS, so they are sharply increase the value of ID with respect to voltage between gate and source. So if the voltage is the VGS, it will decrease, the ID will be decrease. So now this graph is created three region. So these are the saturated local curve will make this area will behave like a voltage control resistors. So in this region the MOSFET will be work at the voltage control resistors, and this is called as the ohmic region. And in this way these are the saturated point, and that point start the ID will be decrease or stop, and this constant. So these all the regions is saturated regions, and when the VGS is equal to VT threshold voltage, their voltage will be is called the threshold. This is region is the cutoff region. So this way three region will be operated. This graph will be same as the depletion mode MOSFET. Now same way here for the P channel. So P channel is here, instead of P here is the N, and VGS is 0. So here is the channel will be created when the voltage will be given is the here terminal is the reverse, the negative terminal voltage here, the negative charge will deposited in the upper side. That's why the positive of the minority charge carrier of N substrates will be deposited here, and that's become make a channel. So that's the same way here will be more VGS will be increasing, and then this is the pinch off condition is there. So here is only change is there, the voltage will be minus, and when the voltage minus will be as shown figure, will be curve will be we get the results. So this way we can discuss about the enhancement mode type as a P channel as well as the N channel. Thank you.